Hello everybody, Mr. Danahower here. Today we're going to be talking about types of energy and a little bit about energy conversions. So some of our goals for today are to be able to describe the basic forms of energy that exist in the universe, understanding the difference between kinetic and potential energy, classifying different things as being kinetic, potential energy, and then categorizing it further, and then also discussing a little bit about the law of conservation of energy. So we'll get started. First of all, what is energy? Pause for just a second. I'd recommend that you take a second and grab some paper to write some notes down. There's going to be a few key concepts that you really need to make sure that you understand. So on your own piece of paper, go ahead and take out a piece of paper and you can title that energy types. And the first thing we're going to do is simply define energy. So energy is the ability to do work. That's the physics definition or scientific definition for energy. So that means that we need to understand, well, what is work? Work simply is caused by a force, a push or a pull, and that is causing some kind of movement of something, which is how we define energy or work. So energy is the ability for something to do work. So some examples of work would be a car here driving. Another one would be an example of a bomb going off and the work that's caused by all of the expanding gases pushing out in all directions. Or another one would be a glass shattering here. Work is being done on that glass from actual sound waves, which are a type of energy that we'll explore today. So first of all, we need to categorize energy into two main categories. So energy can always be divided into either being kinetic energy or potential energy. Kinetic energy is the energy of motion. Anytime something is moving, right, that thing has kinetic energy. Potential energy, though, is the energy of position or stored energy. So it's the energy where we could do work. Remember, energy is the ability to do work. So if something like a rock is really high up on a hill and it can fall down and do some work on the hillside or other rocks around it, that's potential energy. So you should definitely define these, write these down. Kinetic energy is the energy of motion. Potential energy, just like it sounds, it has the potential to do work. Now we're going to divide up types of energy into either being potential energy or kinetic energy. Now one thing I want to stress is that if you go and start doing some research on your own on the different types of energy, different websites or textbooks will use somewhat different terms for some of these types of energy, and sometimes they'll categorize two types of energy together. And so if you look up, how many different kinds of energy are there? Sometimes you'll see 7, sometimes you'll see 9, sometimes you'll see 10. So it kind of depends, and it's just a different way to categorize the different types of energy. So if you see some discrepancies in the lesson today compared to websites or books that you see, know that there's not really a main difference. It's just how they're categorized or clumped together. So let's start with the different types of potential energy. You should write all of these down in your notes. The first one we'll talk about is chemical energy. So we have lots of things in the universe that are bonded together, all kinds of different elements that are either sharing electrons or ionically bonded together. And there is energy, potential energy, in the bonds between those molecules. A great example of chemical energy would be our gasoline that we use in our gas-powered engines. Those are very long chains of carbons and lots of hydrogens bonded together. And when we do the chemical reaction of combustion, we break those chains apart, we break those bonds, and we reform new compounds like water and carbon dioxide. And in that process, a lot of energy is given off. And we harness that energy and use it for other types of energy. So chemical energy is stored in our food that we eat, in wood, like if you're burning wood in a fire, in fossil fuels, lots of different examples of chemical energy. The next one is elastic energy. So if you've ever stretched a rubber band out, you have put potential energy into that band. It has the potential to do work, and maybe you're about to shoot that at your little brother or little sister. Not condoning, just saying maybe you've done that before. So you are putting energy into elastic potential energy into that rubber band. Another example would be like a bow and arrow stretched out. So you're bringing that string back with your arrow in it, and it's ready to do some work. It's got elastic potential energy, stored energy there. Another example of potential energy would be nuclear. So in our lessons about nuclear reactions, fission, fusion, and decay, we know that there's energy stored in the nucleus of all atoms. And so an example would be like with fission. When we break that nucleus apart, we throw a neutron at a heavy uranium nucleus and we break it apart, a lot of energy is released in that process. So there are forces at play inside of that nucleus that give it a lot of potential energy. And nuclear reactions, especially nuclear fission that we use in nuclear power plants, they give off a very large amount of energy. So nuclear energy is a very dense kind of energy, meaning there's a lot of energy in a nucleus. And that's why many countries use a lot of nuclear power for their main power source. Of course, there is some controversy about that because we've got to store the leftover nuclear material somewhere safe for a very long time, and that can be a little bit of a challenge. And we have had some issues of plants melting down, for example, Chernobyl that happened a long time ago, and then not as long ago, the plant in Fukushima. So we have to be careful about where we put those and have a lot of safety mechanisms in place. The next example that you're probably most familiar with is gravitational potential energy. So that's really just defined as the energy due to its position, and I should add on to that, gravity matters here, okay? So if we have an object, like you climb up to the top of a diving board to jump in and do your best belly flop, all right? As you go up, you are higher and higher off the ground, and you are investing gravitational potential energy as you get higher off the ground. Gravitational potential energy is based on the mass of an object and how high it is off the ground. So the higher something is and the more massive it is, the more gravitational potential energy that it will have. We'll explore gravitational potential energy a little bit with our skate park simulation that we'll do, and I'll talk a little bit about at the end of this video. So let's see how you do at classifying these different types of energy now. So look at each one of these, number 1, 2, 3, and 4, and see if you can classify each one of those as being of what kind of potential energy is displayed for this picture. If you want to pause and do that for a second, and then we'll go over answers together. Okay, so number 1, you should have picked elastic potential energy. Again, like I said with the bow and arrow, you're pulling that back and you're bending it and you're storing energy, elastic energy there. Number 2, we have the process of fission. So this is going to be a big nucleus. It's getting hit with a neutron and releasing a lot of energy in that process. So that's going to be nuclear, stored nuclear potential energy. Number 3, what's keeping our planet in its orbit around the sun? And that would be gravitational potential energy. So the gravity from the sun is holding the Earth in its orbit and all of the planets. So that's one bigger picture of gravitational potential energy. There is a certain amount of gravitational potential energy that the Earth has because of the gravitational pull of the sun. Most of the time when we look at gravitational potential energy, we'll focus on things on Earth and them being off the ground a certain distance. And then the last one, you see gasoline going into the car, and that's an example of a fossil fuel. And like we said in the previous slide, that would be an example of chemical energy. The chemical energy is energy stored in the bonds between molecules, bonds between atoms that are in molecules. Okay, so hopefully you did okay classifying those. I would like you to take a second and just think about other examples around you right now of potential energy. So maybe just look around, think about wherever you are in the house or the classroom. What are some things that have nuclear potential energy, elastic potential, chemical potential energy, or gravitational potential energy? Let's go ahead and move on to the 5 types of kinetic energy. Remember, kinetic energy is anytime an object or something has motion. Now we're talking about kinetic energy. So the first one we'll talk about is radiant energy. This can have different terms. This is one where you might see it called different things. And so light energy, you might see it called light. But really what we're talking about here is all electromagnetic waves. So anytime that an electromagnetic wave is moving, that is going to have kinetic energy because it is a transfer of energy by a wave. And we'll discuss that farther along in our energy unit. We'll talk more about the types of electromagnetic waves. So light energy would be the best example of that we see every day, that radiant energy that we see around us. That's how we see most of everything that's in our world around us. But also other types of electromagnetic waves, like the microwaves or radio waves that your cell phone uses. Those are radiant energy. The microwaves that you use to heat your food, if you're heating up your lunch today. The ultraviolet rays that we put on sunscreen to protect us against the harmful ultraviolet rays. The X-rays that are used to take an X-ray of your teeth or your arm that you might think is broken. So lots of different types of radiant energy here. Let's talk about thermal energy now. In thermal energy, what's moving, and this is often called heat energy as well. The particles are actually what's moving or vibrating. So let's just take an example. We'll take a water, and I've got a water molecule here. I've got a few water molecules, okay? In my water molecules, anytime on Earth, there's every substance, the particles are vibrating at least a little bit, okay? The faster they're vibrating and moving, the more thermal energy they have. How could we measure that? How would we measure how fast those particles are vibrating? And we take the temperature. So when we take the temperature, we're really just taking a measurement of how fast the particles are moving in a substance. So if I have my water molecules here, and they're vibrating and fixed in place, right, in a solid phase of matter, if I give them some energy, if I have these water molecules absorb some energy, they might start vibrating more and more. Okay, their temperature is increasing, and they're going to potentially melt and become a liquid and be able to move around easier, right? If I continue to put more thermal energy in, heat energy, that's going to cause them to vibrate and move so fast that they're going to break apart from each other and become water as a gas, right? They're going to move into the gas phase. So anytime that you are measuring temperature, you're really just measuring how much thermal energy something has. And that's due to the particles that are vibrating. By the way, if we cool that water off, right, if they're moving really fast and we put them in the refrigerator or freezer, they're going to start to lose some of that kinetic energy because they're hitting other particles that are moving slower, and they're losing that energy as they hit slower moving objects. And that's how we would lose that heat energy and cool things off. The next one is the energy of motion. Sometimes this is called mechanical energy a lot of times. So you might want to just write this down as the energy of motion in general, or just mechanical energy. Both of those are terms that we'll be using. This is usually the term we use for, larger objects around us that are actually moving. So a car, or a person running, or a dog jumping to catch a frisbee, a ball being thrown. All of those things have kinetic energy because they're objects that are moving. And again, we'll look at the mechanical energy, or the energy of motion, which we'll just call kinetic energy sometimes. In general, we'll just say the energy of motion is kinetic energy. And we'll look at that a little bit again in our skate park simulation that we're going to play with a little bit today. The next one would be sound waves. So sound waves really are just air particles, usually, and they could be in water as well. But they are particles that are moving kind of back and forth in a longitudinal wave, which we'll also explore later on. And those sound waves are moving particles. So when I'm talking right now, my voice box, my vocal cords, are basically vibrating the air. And when they do that, it's causing that sound to go out in all directions. And that sound wave, that longitudinal wave of compressed and expanded particles, just moves throughout the air around us. So why is that kinetic energy? Because either the air or the water, if the sound is moving through water, or even it can travel through solids as well, those particles are actually transmitting that sound by moving back and forth. Lastly, electrical energy, which is sometimes confusing for students. What's actually moving in electricity? And the answer is electrons. So remember those tiny little insignificant mass particles that are cruising around the outside of the atom that have a negative charge? Those electrons moving are actually causing electricity. That's what electricity is, the flow of electrons. It's more complicated than that, but basically, if we turn on a light switch, we are connecting a circuit and allowing electrons to flow through whatever it is that we are trying to. Sorry about the break there. In electricity, so we flick on that switch, those electrons are going to flow to whatever it is that we're trying to make work. So maybe it's just a light bulb, and those electrons are going to flow through the wires in your house. They're going to hit that light bulb, and they're going to flow through the filament or the LED unit, and they're going to cause a transfer of energy to whatever that we want it to be. In your microwave, you have electricity flowing into that, and there's a big magnetron tube that creates microwaves to heat up your food. And so all of electricity is just moving electric charge. That's all it is. So we've got our 5 types of kinetic energy. All of these you should be able to see what's actually moving, right? There's kinetic energy is the energy of motion. Something's actually moving here. Okay, let's do a little practice and see if you guys can categorize each of these in their different types of energy based on what we talked about. So maybe pause for just a second and see if you can determine which type of energy is represented in each one of these. Okay, number 1. All right, we've got a guy on a skateboard moving pretty quick. So this would be either motion or mechanical energy, or sometimes people will just say that this skater has a lot of kinetic energy. Okay, he's cruising along and he takes a little digger here, and we don't want to see what he looks like when he gets up because that's going to be painful. Number 2, here we see some flashlights. What kind of energy is being emitted by those flashlights? And that's going to be radiant energy, also called light energy sometimes, right? Number 3, we see a steaming hot cup of coffee. Coffee is my favorite. So we have in there, that's pretty hot. It has a lot of thermal energy or heat energy. Okay. Number 4, we see electric current moving. We see electrons moving through a wire. May not be obvious on that one, but that would be an example of electrical energy. And number 5, our star from Hamilton here, who is an excellent singer, of course, and that's a representation of sound energy. Okay. So again, all of these involve something moving, some of them a little more obvious than others. A lot of times the movement of the things are at such a small scale that we can't see the motion happening, but there is still movement going on, and that's what are classified as types of kinetic energy. Okay, so we've discussed our 2 different categories of energy, kinetic and potential, easy for me to say, and then we've categorized energy in each of those. We have 4 kinds of potential energy and 5 kinds of kinetic energy. Now let's talk a little bit about the law of conservation of energy. This is a super important law in terms of science and just the world around us. And it just basically says that energy cannot be created or destroyed. It's only transferred. That's the simplest way I can put it. Energy can't be made and it can't be destroyed. It can only change forms. And so a better, more full definition of this is that a total amount of energy in a system remains constant. A system is just, when we're talking about certain objects, or maybe the Earth as a system, or the sun, or the solar system, or maybe just a cup of coffee, like that's our system that we're talking about. In science, a lot of times we have to define, because everything interacts with everything else, we have to define what our system is to isolate the variables that we're talking about. So the amount of energy in a system is always constant, but energy is changing forms all the time. It can't be created or destroyed, but it can change forms. One simple example of that is going to be the energy skate park that I'm going to show you now. And you're going to have an assignment on this that you'll practice just understanding the conversion between kinetic and potential energy. So let me navigate to that, and we will talk through here a couple of things. So to get to this on your assignment, you'll have a link, and you don't need to do this right now, but you'll have a link that takes you here to this simulation. And in that simulation, you're going to be playing with our skater person here. Now, it's important that you notice there are several different factors that you can play with in here. One of those is the mass of the skater. So is it a big person or a small person? And that's going to be really important because mass is going to tie into energy a lot in this simulation. So you want to pay attention to how the energy changes whenever the mass is different. And then really we're going to focus on this bar graph right here. So you're going to click on this bar graph, and we're going to lift our skater up. Right? We've got to give our skater some gravitational potential energy to get her going on the track here. And then we're going to let her go, and we're going to see how the potential energy that she started with changes over to kinetic energy and then back to potential as she goes up and down the ramp. This is a very simple example of the law of conservation of energy, where the energy that's the total energy here, that doesn't change, right? Because what energy we started with is simply being transferred from one form to another. Now you'll notice there's a thermal area here, but right now on our track we don't have friction turned on. Later you'll turn it on and see how that changes, because obviously if you've ever skated or done anything like this before, you don't just continuously go back and forth. You start to slow down because of friction. So one of the things that you're going to have to do with this, and I'm going to put this in slow motion here, I think. All right, well, we're going to take some screenshots of the graph at these different locations. So I want to show you how to do that. So when the skater's at this position, what is the kinetic, potential, and total energy like? What we're going to want to do here, okay, so to take this bar graph and put it over onto our assignment, we're going to use what we call the snipping tool. You guys are probably familiar with this, but it's a handy tool, and you can basically take a screenshot of whatever you want. So in your menu on your computer, open up your snipping tool when you get to this point, and you'll just click New, and it'll gray the screen out a little bit. And we'll come here and take a screenshot of my snipping tool is not working. Hold on a second. Okay, so we're going to go ahead. It's not allowing me to screenshot during the video, so I'm just going to basically turn the snipping tool on, click New, and so that's going to be right here. And for some reason, I don't think it's letting me do that while I'm recording the video. So I'm going to click New, and then I'm just going to select this whole bar graph right here. So I'm going to do that, and then I'll show you what that looks like. Okay, once you've snipped it, it's going to look like this. So you now have that bar graph with potential, kinetic, and total energy on it. We can come up here and click on Copy, and then what we'll do is go to our assignment, which is going to look like this. Okay, and I want you guys to place an energy bar graph at positions A, B, and C. So you're going to need to put 3 different bar graphs on this. And so we're going to right-click and paste this in here. Now it's going to be really big, so don't worry about that. Just resize it. All right, and then we also want to change how it displays on the page. So right here, if you click on wrap text, that's going to work a little bit better, and it's going to allow you to move this around. So we're going to take this, and we're going to place it over here at position C. Okay, so now we've placed one at position C. We also want to place one at position B. So again, you'll come back here, and you'll let your skater go down to the bottom, pretty close there. That's close enough. Don't pick her up and move her, because if you do and put her at the bottom, now she didn't start with any energy. So she does have to start at the top. So she's got some potential energy here, and we'll stop her pretty close to the bottom. We'll take another screenshot of that, and then we'll paste that in position B right here. Then we'll do the same thing for position A. All right. Down at the bottom of the assignment, the fun part of this is you get to make your own track in the playground. And so you'll do that, and then you'll snip 5 different bar graphs depending on where your position is on your track that you want to show us. So I wanted to just go through that really quick so you understand how you're going to be using this simulation to show the conversion between kinetic and potential energy for this assignment, and the part of snipping the bar graphs so that you can put that into your assignment. That's all for today. I hope you learned a little bit more about the types of energy and a little bit about the kinetic and potential energy transfer with the skate park, and you'll explore that a little bit more. I hope you have a great day, and Go Ridge!